Hi everyone, this is Dr. Meenambika, Associate Professor and Head, Department of Science and Humanities, Shri Shanmugha College of Engineering and Technology, Sangagiri. In continuation of last video, today we are going to see characteristic equation, eigenvalues and eigenvectors. So the very first one is characteristic equation. If A is any square matrix of order n, then A minus lambda I equal to 0, that is determinant of A minus lambda I equal to 0 is called the characteristic equation of the given matrix capital A. The characteristic polynomial, that is the determinant A minus lambda I equal to 0, which when expanded will give a polynomial which is called as the characteristic polynomial. Now we will see the working rule to find the characteristic equation. So I have given two types of matrices, that is 2 by 2 matrix, and the next one we will see about 3 by 3 matrix. For 2 by 2 matrix, so let the matrix be 2 by 2 matrix with elements A11, A12, A21, A22. Then its characteristic equation is defined as, see, it is written as lambda squared minus S1 lambda plus S2 equal to 0, where S1 is nothing but the sum of main diagonal elements of the given matrix. So when we see what are the diagonal elements, it is A11 plus A22. And S2 is nothing but determinant of A. So determinant of the given matrix A is nothing but A11, A12, A21, A22. So this matrix when expanded will give an equation or will give some value that is called as S2. So when we go back and substitute here in the characteristic equation, we will get the characteristic equation of the given matrix for 2 by 2. Now the characteristic equation, how to find out the characteristic equation for 3 by 3 matrix. So let us take a 3 by 3 matrix with elements A11, A12, A13, A21, A22, A23, A31, A32, A33. Then its characteristic equation is defined as lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0, where S1 is nothing but same like 2 by 2 matrix. It is sum of main diagonal elements, that is A11 plus A22 plus A33. And S2, how do we find out S2 in 3 by 3 matrices? Sum of minus of main diagonal elements. So which is nothing but I have to fix with this first diagonal element A11. I have to leave the corresponding row and column. So the resultant elements I have to put it in matrix. So it is A22, A23, A32, A33. Plus the next diagonal element is A22. I have to fix up with this diagonal element A22. I have to leave the corresponding row and corresponding column. So I get A11, A13, A31, A33. Plus the next diagonal element is A33. The similar procedure we have to follow. Leave the corresponding row and column. So I get A11, A12, A21, A22. And S3 is nothing but determinant of A. So this is how we find out S1, S2, S3. Go back to the characteristic equation, substitute the values. We get the characteristic equation of the given matrix. If A is a null matrix of order 2, if A is a null matrix of order 2, just you imagine if the matrix A is a null square matrix, you all know what is null square matrix, then what will be its characteristic equation? So its characteristic equation is lambda squared equal to 0. Now coming to eigenvalues and eigenvectors of a matrix. The definition of eigenvalues is, let A be a square matrix. The roots of the characteristic equation are called the eigenvalues of capital A. Whenever we have a square matrix, we will be able to find out the characteristic equation, what we have seen in the previous slides. So when I am able to solve the characteristic equation, we will get some answers. That is, we say it as roots. That is called as the eigenvalues of capital A. Next, coming to the definition of eigenvector. If there exists a scalar lambda and a non-zero column vector capital X such that I am able to write it as Ax equal to lambda x, then lambda is called the eigenvalue of capital A and capital X is called the eigenvector of capital A. So this is the definition of eigenvalues and eigenvectors. Now we will see one result based on this eigenvalues. Show that the eigenvalues of a null matrix are 0. you have to recall the concept of what is a null matrix, what is the definition of eigenvalue, what is characteristic equation, all those things. Now let me take a null matrix capital A equal to with all 0 entries. The characteristic equation is A minus lambda I equal to 0. See, when A minus lambda I means A is the given matrix, lambda is the scalar, and I is nothing but the identity matrix. Okay, so I will get the resultant matrix as first element is 0 minus lambda into I. So I is nothing but 1. So I get 0 minus lambda, everything in the diagonal elements. All other elements will be 0. So I get minus lambda the whole power n equal to 0. That is, we have n by n matrix. So minus lambda the whole power n equal to 0. This means minus lambda equal to 0. And last we get lambda equal to 0. Now we will see the working rule to find the eigenvalues and eigenvectors. So the very first step is we have to find the characteristic equation A minus lambda I equal to 0. Second step is we have to solve the characteristic equation. We get the characteristic roots. They are called the eigenvalues. To find the eigenvectors, we have to solve the equation A minus lambda I into x equal to 0 for the different values of lambda. So there are 4 types to solve this eigenvalues and eigenvectors. The first one is non-symmetric matrices with non-repeated eigenvalues. So when a problem is given, you have to identify whether the given matrix is symmetric or non-symmetric. So non-symmetric matrices with non-repeated eigenvalues. Second one is symmetric matrices with non-repeated eigenvalues. Third is non-symmetric matrices with repeated eigenvalues. And the last one is symmetric matrices with repeated eigenvalues. So this is what last one, there will be a small change in the procedure which we are doing. Others will be similar to the problem. Okay. Now we will see one type problem along with the 3 by 3 matrix. So non-symmetric matrices with non-repeated eigenvalues. So the question is, find the eigenvalues and eigenvectors of a given matrix 11 minus 4 minus 7, 7 minus 2 minus 5, 10 minus 4 minus 6. So what I have mentioned here is the year of the question in semester. That is what I have mentioned here. Now let me take the matrix, given matrix as A matrix. My first work is I have to find out the characteristic equation. So S1 is nothing but sum of diagonal elements. So it is 11 minus 2. See, observe the diagonal elements. It is 11 minus 2 minus 6. So I get S1 value as 3. Next, S2 is nothing but sum of minor of diagonal elements. So first diagonal element is 11. So as I explained earlier, it is 11. Minus 2, minus 5, minus 4, minus 6 is the first determinant. Next, take the next diagonal element minus 2. When I leave the corresponding row and column, I get 11 minus 7, 10 minus 6. Plus next diagonal element is minus 6. Leave the corresponding row and column. So you get 11 minus 4, 7 minus 2. So just expanding this determinant. Minus 2 into minus 6 is plus 12. Minus 4 into minus 5 is nothing but 20. Plus 11 into minus 6 is minus 66. Formula, there is a minus. 10 into minus 7 is minus 70. So minus into minus becomes plus 70. Plus minus 22 minus 28. So I get plus 28. So the answer is minus 8 plus 4 plus 6. So S2 value is nothing but 2. Now to find out S3, S3 is nothing but determinant of A. So I want to expand the determinant. So it is, I am going to expand the determinant along first row. So 11 when I keep it outside, I get minus 2, minus 5, minus 4, minus 6. Then formula, there is a minus and the element has minus 4 times. So I have to leave the corresponding row and column. So I get 7 minus 5, 10 minus 6. Plus next element is minus 7. So I have to leave the corresponding row and column. So I get 7 minus 2, 10 minus 4. So when I just do all the simplification, I get 11 times, this is minus 2 into minus 6 is 12, minus 4 into 5 is 20, minus into minus is plus 4, this is minus 42, minus of minus 50 is nothing but plus 50, plus into minus I get minus 7, this is minus 28, this is minus into minus 20, so I get plus 20. So 11 into minus 8 plus 4 into 8 minus 7 into minus 8. So it is minus 88 plus 32 plus 56. So S3 value becomes 0. Now the characteristic equation is, as we discussed earlier, it is lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. So when I substitute S1, S2, S3 value, I get lambda cube minus 3 lambda squared plus 2 lambda minus 0 equal to 0. So I get lambda cube minus 3 lambda squared plus 2 lambda equal to 0. So this is the procedure what we follow to find out characteristic equation. So next I have to find the eigenvalues. That is, I have to solve the characteristic equation and I have to find the eigenvalues. So the characteristic equation, when I observe, I have lambda in common in all the terms of the characteristic equation. So lambda cube minus 3 lambda squared plus 2 lambda, I can take 1 lambda common outside. So it becomes lambda squared minus 3 lambda plus 2 equal to 0. So this means lambda equal to 0 or lambda squared minus 3 lambda plus 2 equal to 0. So when I just solve this quadratic equation, that is lambda squared minus 3 lambda plus 2 equal to 0, sum is minus 3 and product is 2. So we all know that how to do is, this is 2, this will be minus 3. So what are the values I can put? Minus 1, minus 2. So when I multiply, I get 2. When I add up, I get minus 3. So the value is nothing but lambda equal to 1, 2. So what are the eigenvalues now? So the eigenvalues are, first eigenvalue is lambda equal to 0. Next I get lambda equal to 1, lambda equal to 2. So these are the eigenvalues 0, 1, 2. So at this point we have to check whether the eigenvalues are repeated or non-repeated. So here we have 3 different eigenvalues. So it shows that it is non-repeated. Okay, that is what the type we are solving also. Now next we have to find the eigenvectors. So to find out the eigenvectors, I have, for the first case, I will take lambda equal to 0. That is the eigenvalue lambda equal to 0. What is eigenvector? We know the formula a minus lambda I into capital X equal to 0. So a minus lambda I into capital X equal to 0 means it is a minus 0 I into X equal to 0 because lambda value is 0. So this shows that it is Ax equal to 0. What is A? A is nothing but the given matrix. So write down the given matrix here. Then capital X is nothing but x1, x2, x3, which is equal to 0. Now let me select the last 2 rows. When I select the last 2 rows, I get x1, x2, x3 I will write here. When I write x1, I have to leave the x1 column. I have to write minus 2, minus 5, minus 4, minus 6. And when I take x2, I have written, see x2 means you have to leave this column. See the remaining columns, minus 5, minus 6 is written, 7, 10 is not written, so that you have to write here. And x3, when I write x3, you have to leave the x3 column. When you just observe, 7, 10 is written, minus 2, minus 4 is not written, so that you have to write. x1 divided by, this is the formula, x1 divided by, you have to cross multiply this. So 12 minus 20 and x2 divided by minus 50 plus 42 and x3 divided by minus 28 plus 20. So in the denominator we are getting all together as minus 8, x1 divided by minus 8, x2 divided by minus 8 and x3 divided by minus 8. So when I just do the simplification, when I divide by minus 8, the denominator becomes x1 by 1, x2 by 1, x3 by 1. So now I define the eigenvector capital X1 using the denominators because we know the vector capital X is x1, x2, x3. So the denominator here is 1, 1, 1. So I get capital X1 is equal to 1, 1, 1. So this is my first eigenvector capital X1. Now, next case, my next eigenvalue is lambda equal to 1. So, when I put lambda is equal to 1, the general formula is a minus lambda into x equal to 0. A minus lambda value is 1 into I equal to x equal to 0. So, what happens? So, a minus lambda I means, so first I want to write the A matrix minus 1. 1 into I is again 1. So, all the diagonal elements will get 1 times x1, x2, x3 equal to 0. So, the resultant matrix is 10 minus 4 minus 7, 7 minus 3 minus 5, 10 minus 4 minus 7 times x1, x2, x3 equal to 0. Now, select the last two rows as such how we did for the previous thing, no? Previous case 1, the same thing. Select last two rows. So, x1, x2, x3. When I write x1, I have to leave this 2. I have to write minus 3, minus 5, minus 4, minus 7. And when I write x2, I have to leave the corresponding column x2. When I observe minus 5, minus 7 is written here. So, 7, 10, I have to write it here. Then similarly, x3 when I take, I have to leave the column x3. When I leave the column x3, the remaining elements will be 7, 10 is already written. So, I will write minus 3, minus 4 here. So, now x1 by just multiply this, you get 21 minus 20, x2 divided by minus 50 plus 49, x3 divided by minus 28 plus 30. So, when I simplify, I get x1 by 1 equal to x2 by minus 1 is equal to x3 by 2. So, the next vector x2 is nothing but 1 minus 1, 2. The last case lambda equal to 2. The same method, a minus lambda I into x equal to 0. Put lambda equal to 2. So, you get 11 minus 2, minus 2 minus 2, minus 6 minus 2 in the diagonal. And apart from the diagonal elements, all elements remains to be the same. Times x1, x2, x3 equal to 0. So, the resultant matrix is 9 minus 4 minus 7, 7 minus 4 minus 5, 10 minus 4 minus 8 times x1, x2, x3 equal to 0. The same way we will select last two rows and we will write the elements here. So, I get x1 by, see, minus 4 into minus 8 is 32, minus 5 4s are 20 equal to x2 divided by minus 50 plus 56, x3 divided by minus 28 plus 40. So, I get x1 by 12, x2 by 6, x3 by 12. Just by simplification, when I divide by 6, I get x1 by 2, x2 by 1, x3 by 2. So, now I have got 3 eigenvectors x3. x3 is nothing but 2, 1, 2. So, what are my eigenvalues? My eigenvalues are at the end of the problem. I can just tell the eigenvalues are 0, 1, 2. And the first eigenvector x1 I got it as, what is the first eigenvector I got? I got 1, 1, 1. 1, 1, 1 is the first eigenvector. And what is the next eigenvector x2? So, previously by using the value lambda equal to 1, we got the x2 as 1 minus 1, 2. 1 minus 1, 2. And what is x3 we got? We got x3 as 2, 1, 2. So, in the next class, we will see the next type of problem, that is non-symmetric matrices with repeated eigenvalues we see. Thank you.